So for PN junction diode, if we find out, we have VA characteristics. We have VA characteristics. From VA characteristics, if you find the slope of the curve gives resistance. That already you know. How? So see, V is equal to R equal to V by I. Just find out the slope of the curve, then we'll get resistance. So RD, we write resistance of the diode is given by delta V by delta I. Is given by delta V by delta I. From the slope, see here, this is the curve. You find out the slope like this. Find out the slope. So this is delta I and this is delta V. Okay. So delta V by delta I, here y coordinate by x coordinate. Y coordinate by x coordinate. In this case, it should be 1 by R is equal to what? 1 by R equal to, so y coordinate is this one. Y coordinate is this, delta I by delta V. So 1 by R will be delta V by delta I. Understood now? In this case, see this, R should be, if you take R here, see, y coordinate by x coordinate is delta I by delta V. But delta I by delta V will not give resistance. It will be R. So 1 by R is equal to what? Delta I by delta V. Clear? So now next here, this is the way we find out the resistance of the diode. Then applications of the junction diode. First application. What is applications of diode? Applications of diode. The first one, it is used to convert, that is, we say rectifier. What is a rectifier? Rectifier is a device which converts AC to DC, alternating current to direct current. For that purpose we use. Generally this is used in adapters. It is adapters of laptop or mobile chargers. In that we use this, and also in the laptops, adapters, laptops and chargers, we use this. Okay, rectifiers we use. Even in the CFL lamp also, in the CFL lamps also, we use these rectifiers. The second one is to block the current. Okay, to block current in the batteries, to leave the, okay, they are used in batteries to block current to leave the battery. Okay, we don't want the current to leave the battery, so we connect the diode in the reverse mode or reverse bias so that the current will not flow. Okay, for that purpose we use. Next we will go to the rectifier. Okay, we'll go to the rectifier. One second. So in rectifier we have two types of rectifier: half wave rectifier, a rectifier. In that we have to, in our textbook they have only given two, that is half wave rectifier. The second one is full wave rectifier. Half wave rectifier, full wave rectifier, and the third one is bridge rectifier. But bridge rectifier is not there for you. The usually used rectifier in all the devices is a bridge rectifier, but this is not there in our syllabus. But to understand bridge rectifier, first of all you should understand, you should know how, that is, you should understand first how the rectifier works. Now see here, we have a first, see, we have to, how is the process, I will tell you, in half wave rectifier or full wave rectifier, whatever the rectifier is. So first the voltage has to drop. Voltage has to drop from 230 voltage AC to maybe 20 volt AC or something like that. So for that purpose we need to use a step down transformer. We need to use step down transformer. After using step down transformer, Okay, after using this, so voltage will come down. Once it will come down, there is a diode. Okay, then there will be a output. Okay, this is the way that the rectifier is built. Now, if you go with half wave rectifier, if you go with half wave rectifier, now, so first we will have a supply. So this is from see, this is the AC current. Now, so this is the battery. Okay, this is a diode now. So this is the resistor and this is the output. So this is RL, load resistor. This is a load resistor and this is the V output, VO. Okay, VO we write like this. See once again, this is a transformer. Okay, this is a primary coil, secondary coil, and this whole setup, this one, this is said to be a transformer. This is said to be a transformer. This is AC current, transformer, diode. This is a diode. And this is diode, and these two are the X and Y points. This is load resistor and this is the output voltage. Understood now? Is it clear? See, this is the AC current. This is a transformer, step down transformer. I'll write here. It is a step down transformer. In step down transformer, what happens? Number of turns on primary are greater than number of turns on secondary. Okay, voltage on primary is greater than voltage on secondary. Current on primary is less than current on secondary. Okay. So for you, this is not required for you. Okay, so just only will try to explain with this concept. So what will happen? Only one diode is working. Did you understand this diagram, all of you? Yes, sir. Sayam, did you understand this?
Yes, sir.
Circuit. Okay. Now next one here. I am going to draw the that is a waveform. How will be the waveform? How will be the waveform? See here. This is the waveform. This is the input. But the diode only conducts in the forward bias, not in the reverse bias. So only when the current is flowing in the forward bias, only it will, when it is going in the opposite direction, it won't work. So this is the output. Understood? So if you find the efficiency of this diode, it is coming around 40.6. Okay. Efficiency means what? Output upon input. Output upon input into 100%. So eta is found to be 40.6%. Okay, this much is the efficiency of the half wave rectifier. Then comes full wave rectifier. Okay, then comes full wave rectifier. Okay, first you copy this diagram. Just give me 2 minutes. I'll be joining. Okay, I'm going. Okay, I'm going ahead with the full wave rectifier now. In full wave rectifier, you'll see how it works. Right? So in full wave rectifier, so there is a circuit diagram first. In both the cases, we use step down transformer. Now, this is a diode. See, there are two diodes. In half wave rectifier, there is only one diode. But in full wave rectifier, there are two diodes. Now, from here, there is a center tap. This is X and this is Y. This is RL. RL is said to be load resistor. This is output. and this is diode D1, this is diode D2, and this is center tap. What is the purpose of center tap? I will tell you. This is center tap, and this is a transformer. Okay, this is AC supply, and this is a transformer, step down transformer, step down transformer. We cannot directly convert 230 voltage AC to 5 volt DC. It's not possible, impossible to do that. So for that, we have, first of all, we have to use a transformer, step down transformer, then we use two diodes. Now how it works? See here. Now how it works? Now see, this is the okay, wait, I will draw the this is the input. This is my input, which is given to the diode. To input to whom? Input to D1. This is the input to D1. Now the second one is what? We change the phase and give it 180-degree phase change and give it to the D. If I give the same to this one also, both of them will give only this type of, output. Okay, only this same output will be given. So this is of no use. It will be again a half a rectifier. So this input to D1, the phase is changed by 180 degrees and given to, see, and given to the diode. Okay, phase is changed by 180 degrees and given to the diode. See, when this is like it goes in this way, this is 180-degree phase change. This is 180-degree phase change. This type of signal is given to D2. Now what is output of D1? If you see carefully, the output of D1 is only this much. Okay, this is output of D1. Are you understanding? Similarly, what is the output of D2? See, only diode only will work for the positive half cycle. It won't work for the negative half cycle. So it will only work for the positive half cycle. So what will happen? See here. This is output of D2. Now if you combine together output of D1 and D2, it will be like this. See, this is output of D1 and D2. This is output of D1 and D2. Is that clear? So this is input of D1, input of D2. This is 180-degree phase change. So output of D1, output of D2, then combine together, output of D1 and D2 together. Is it clear? Yes, sir. RL is here. Keep that in mind. RL is said to be the load resistor. So at the output we keep one resistor, and across that resistor we find the voltage. We determine the voltage, or we take the output voltage. Okay. So this is how it works. Once again, see here. In full-wave rectifier, there is a power supply, and this is a transformer. It will step down the transformer from 230 voltage to maybe 20 or 30 voltage. Then there are two diodes, D1 and D2. Then what will happen? These two diodes are connected to the load resistor here. Okay, load resistor. So RL is the load resistor, and this is the output. Okay. So what exactly it is doing? It is changing the phase by 180 degrees and given to D2 like this, in this way. This is the input of D1, input of D2. So output of D1 is like this, output of D2 is in this way. So combined together, D1 and D2 will be in this way. Is it clear now? Yes, Mr. Sayyam and Ibad. Sorry, Zayam. Is it clear?
Yes, sir.
Okay. Now going to the next one, special. So we have now so these are set, like suppose we cannot give this type of output to any electronic device because these are like ripples. Okay, we want a uniform. When I speak about DC, when I speak about DC power supply, it should be, see, AC will be like this. That already we know. This is our AC supply. This is AC supply. But in DC supply, how it will be? It should be like this, in a straight one. Okay. Voltage should be uniform. Understood? Voltage should be constant in DC power supply. Okay. So what happened here? Now the output of the rectifier is taken here. This is said to be filtering circuit. Okay, filtering. filtering. How is the filtering done? So the AC is taken here. So first take down this now. First of all, you take down, draw this once for a practice. Draw this, then I will teach you the next rectifier one, the capacitor one. Yes, sir. Are you done with this? Now, I am going with the filtering part now. I am going with the filtering one. So, in the filtering circuit, sorry, sorry. Now, rectifier. So here, what will happen now? So RL is the load resistor. This is positive, negative, and this is X and this is Y. AC. The rectifier is given and DC component. And RL is this is IL is the current RL and this is DC. Clear? See? AC, this is the AC current, rectifier, and this is the capacitor. And RL is the load resistor, IL is the load current, and this is the DC supply. So why we are using a capacitor now? Why are we using a capacitor? See, the output of a full wave rectifier, how it is? It is in this way. If you look at the output of full rectifier, it is like this. This is the output of a full wave rectifier. Next one. Now, so what we are doing now? See, when the capacitor is already having some charge. So what will happen is when the signal is going up, the capacitor gets charged. Now when it is going down, the signal will get discharged. See, here it will go like this, in this way. It will discharge in this way. And see, just I will draw this with dotted line, okay, so that for a clear understanding. This is the output of a full wave rectifier. So it will discharge in this way. Then again little it will charge. Again discharge. Again it will charge. The capacitor will charge. Again it will discharge. It will charge. Again it will discharge. If you look at this pattern, it's almost all it is a straight line. See, it is almost all a straight line. This is said to be the filtering. Okay, output with capacitor input filter. Capacitor input filter. Earlier I used to tell you when I was teaching electromagnetic induction, I used to tell you that capacitor is used for charging as well as it is used for filtering purpose. Capacitor is used for to store electrical energy as well as it is used for filtering. Whereas inductor is also used for inductor circuit, or inductor is also used for storing magnetic energy as well as it is used for filtering. This is the way how we filter. See, when the signal goes up, it will charge, but when the signal is going down, the capacitor will discharge. Again it will charge. Again it will discharge. Again, to understand the property of the capacitor, charging and discharging of the capacitor study is required. But charging and discharging of a capacitor is not there in your syllabus. It is removed from your syllabus. Earlier old it was there. So charging of a capacitor and discharging of a capacitor is not required now. But just understand, because when it is discharging, it won't discharge, it won't become zero. It will discharge up to 37% or some 67%. Understood? So if you, best simple example I will give, your phone will charge very quickly from 0 to 67%, 66.6, that is to say 66.7%. After that, the rate at which it is charging will change. Similarly, when the phone is discharging also, up to 36, 37 or 36.7, what we say, up to until that point, the phone will discharge easily. But after 37, the phone is not discharging at the same rate. The rate is changing. This is also an important factor which is used in batteries and the phone batteries or the laptop batteries and all. Okay, well, charging also it is different, well, discharging also it is different. So same way, when it is discharging, it doesn't mean that it becomes zero. That may be a question arising in your mind, like, why sir it won't become zero again immediately? Can you charge only this much and will it discharge? No, it won't become zero completely. It may be 66% or 67% or maybe 37%, we don't know. But again it will charge, discharge, charge, discharge, charge, discharge. So that is why it's almost all becoming a straight line. So what if there may be a question like, sir, what if I don't give directly this type of, anyways it is a DC, this is the output of a full wave rectifier. So we can give, right? But you can give, but your electronic device will get spoiled within a small interval of time. Why? Or a small period of time? Because these ripples are not good for the electronic device. When I say DC, it should be a straight line. Uniform. Uniform. Electrons should go uniform. Flow should be uniform. Not like this. Not like a ripples in this. These are said to be the ripples now. This should not be given to the electronic device. So this is the difference between a branded charger and a local charger. Like suppose, example I will give you. There is a, like suppose if you buy a iPhone or a Samsung phone, they will give a charger with that. That's a branded one. It comes with the phone. But nowadays these iPhone people are not giving the charger also. We have to buy again. Now the price of the charger is coming around 200 dirham, I think 200 or 150. I don't know how much it is in the iStore. It is little expensive. When the outside, when you buy it, it is only 10 dirhams, 10 or 20, not more than that. So what is the difference? The difference is with the filtering. The difference is with the filtering. That is why never charge your phone. Suppose your battery is draining. Don't charge wherever you find a charger. Don't try to plug in. No, never do that. But find out whether the charger is proper or not, whether it is the original one or not. Then you charge it, because after certain times your phone starts behaving in a different manner. Your charging and discharging pattern will change. So that is why try to use a original charger or carry original charger with you, so that you will not have any issues. Okay, why most of the phones policy, only this is the reason. Suppose if you may be seeing some people, they carry they charge with their own charger, it will never spoil. Even laptop, you see, simple example I will give. You have a laptop with you and there is a charger with the laptop. Do you change the battery within a year or 2 years? You don't change. It will work for a long time. Why? Because you're not changing the charger. The charger which came with the laptop, you're using the same thing. So this is a simple example to understand the filtering process. Filtering is very, very, very important. So when you buy a branded one, you will have proper filtering. If you don't buy a good one, then your filtering will not be good and your phone will get damaged. Okay, so it will charge quickly, and that also I'm telling you. There are some chargers, very fast chargers also. Yeah, that is true. But it depends upon the filtering. How fast it is filtering, we don't know. So whenever you, these are the factors to be taken into account when you are using a charger. Now, I am going to the special purpose PN junction diode. Okay, so I explain once again, quick recap what we have done in the PN junction diode. Okay, in the PN junction diode and the VA characteristic, then half wave rectifier, full wave rectifier. See here, in a PN junction diode, this is forward bias and this is the reverse bias. In forward bias, what happens? The P is connected to positive of the battery, N is connected to the negative of the battery. There is a voltmeter connected parallel to the diode, and there is a ammeter connected in series. Ammeter should be connected in series and voltmeter should be connected in parallel. So especially when you are using the ammeter in forward bias, it should be a milliammeter. Means the magnitude of the milliammeter is 10 power minus 3 amps. Now, so what will happen when you connect the diode in forward bias? So the region, the space charge region, I told you all these definitions. What is space charge region, what is barrier potential, depletion region and space charge region is same. What is barrier potential, how much it is for germanium diode, how much it is for silicon diode, and what is the energy gap between a silicon, that is energy gap in silicon as well as in germanium, that I told you. All these values you have to remember. Why? Because all these will be asked in the Viva. So if you want full marks, then definitely you need to work with the with all these definitions. Okay, in the previous class I have already discussed. Now, so what happens here, the region, the space charge region is very thin in forward bias. So current, the charge carriers will flow easily. So that is why in forward bias what happens, as you increase the voltage, current is also increasing. But after certain voltage, what is that certain voltage? That certain voltage is said to be what? Threshold voltage or cut-in voltage. Okay, threshold voltage or cut-in voltage, or there is one more name I have given. What is a knee voltage? Okay, so at a particular voltage like this here, so and as you're increasing the voltage, current did not start flowing through the diode. After maybe 0.6, the current started flowing. This voltage is known as knee voltage or cut-in voltage or threshold voltage. This definition is usually asked in your, if you get a junction diode or a Zener diode in your laboratory in the physics lab experiment, definitely they will ask you this thing. Now now going to the next one. So here, if you look at this, here is a diode and this is a here that is P is connected to negative and N is connected to the positive, and this is a microamp. Okay, and here the voltage is V. So what will happen, as the as the voltage is increasing and the rate at which it is increasing is 0, 1 to 10, like 1, 2, 3, 4. Here it is 0, 0.1. See, look at the intervals, how we are increasing. Now what happens when you are increasing the voltage, very small current flows through the diode, very small current flows, that also, and the depletion region will become very thick. Here in this case it is very thick, here it is very thin. The depletion region becomes very thin and charge carriers flow easily, but here it becomes thick and charge carriers means electrons and holes are repelled. Then what is that current which is flowing? That is said to be leakage current. What is again the leakage current? That is due to the electron hole recombination. Again, what is electron hole recombination? Electron will go and sit in the place of the hole and slowly it starts moving. So that is said to be electron hole recombination. Small current will flow. What happens, sir, if you are increasing more than 10? And what happens if you increase more than 1 here? So the diode will burn. Nothing happens. The diode will lose its property. Okay, so the depletion region will break and it is no more a diode. Okay, so that is why never increase. So that is why sometimes on the board so that is why the ready-made boards are having a fixed voltages. So even if you increase, nothing will happen to that. Or suppose if you change the voltage system and suppose instead of using for forward bias, if you connect for reverse bias and increase up to 10, finish, your diode is gone. It will not show the readings properly. So this is a problem with the diodes. Okay, so that is why you have to connect it properly. Now so if you increase beyond 10, what will happen here? In the beyond 10 here, when you increase the voltage, what happens? There's a breakdown voltage. Means that for a small change, small change in the voltage, large flow of current is taking place here. This particular voltage is said to be breakdown voltage, BR. So if you increase small voltage, more current will flow through. So that is said to be breakdown voltage. Now, so you might have seen here for the threshold voltage for germanium is 0.2 volts, for silicon it is 0.7 volt, and the voltage is when the voltage is 1 volt, the current is 30 to 80 milliamperes. And in reverse bias there is a breakdown voltage. This you should know. In forward bias you should know what is knee voltage or a threshold voltage or cut-in voltage, the same thing. And in reverse bias you should know what is a breakdown voltage. These are the important terms. Okay, now after that we have how to find out the resistance of the diode. You already know that when we find out those when we find out the slope of VI curve, we get resistance. So here what will happen in this case? So this is not required, don't copy this one. So this is not required. So only we will do RD. RD is equal to resistance of the diode. There is delta V by delta I. Now just find out the slope. Okay.